Every detail in this story comes from real scientific research and observation. Welcome to Quiet Science at Bedtime, a channel where the universe puts you to sleep. Tonight, we are going somewhere you have already been. You were there on April 8th, 2024, or at least the planet you live on was. The moon moved directly in front of the sun, and for a few extraordinary minutes, one of the rarest alignments in the solar system unfolded over North America. Millions of people stepped outside, tilted their heads back, and watched the daytime sky turn dark. But most of them saw only the surface of what happened. Tonight, we go deeper. We follow the physics, we trace the geometry, we stand inside the shadow and understand exactly what it means, what is burning above you, how old that fire is, and why the moon fits so perfectly in front of it that scientists still study the coincidence. This channel is still very new, and if this kind of storytelling helps you rest, it would mean a great deal if you subscribed, left a like, and turned on notifications. Every episode is grounded entirely in real science. What you hear tonight is not fiction. Just relax and feel free to let this play as you drift off to sleep. Now, let us begin. On April 8th, 2024, the moon's shadow traveled across the surface of the Earth at approximately 2,500 kilometers per hour. It entered the North American continent over the Pacific coast of Mexico's Sinaloa state, swept northeast through Texas, Arkansas, Illinois, Indiana, Ohio, and New York, and exited over Newfoundland, Canada, before dissolving into the Atlantic Ocean. The entire crossing took roughly 90 minutes. The zone of totality, the narrow corridor where the sun was completely blocked, was no wider than 185 kilometers at its broadest point. Inside that corridor, something happened that most people on Earth will never experience in their lifetimes. The sky darkened. Not the slow dimming of sunset, not the gradual shift of a cloudy afternoon. This was a sudden, directional, geometrically precise darkness that arrived from the west like a wall. Animals grew quiet, birds returned to their roosts. The temperature dropped by as much as 10 degrees Celsius in less than 5 minutes. And in the sky above, where the sun had been blazing at a surface temperature of approximately 5,500 degrees Celsius, there was now only a black disk ringed by pale, streaming fire. That fire is called the corona, and tonight that is where we are going. You are standing on a wide field somewhere in central Texas on the morning of April 8th. The sky is cloudless. It has been cloudless since before sunrise. Around you, hundreds of people have set up blankets, folding chairs, and telescopes. There are children lying on their backs in the grass. There are scientists with spectrographs mounted on aluminum tripods. Someone nearby is holding a pair of Eclipse glasses, waiting. It is 12:17 in the afternoon, local time. The sun is high and fierce. It sits at an altitude of roughly 64 degrees above the southern horizon, nearly overhead. You are looking up through eclipse glasses, and the sun appears as a small, perfect orange circle against a field of black. There is nothing unusual about it yet. It is just the sun, burning at the center of the sky the way it has burned every clear day of your life. But 384,400 kilometers away from where you are standing, the moon is in motion. It is moving at 1.023 kilometers per second in its orbit around the Earth. that is slightly over 3,600 kilometers per hour, fast enough that it circles the entire planet once every 27.3 days. And on this particular orbit, its path through space has placed it precisely between the Earth and the Sun. Not slightly off-center, not partially aligned, precisely aligned to within a fraction of a degree. The Moon's diameter is 3,474 kilometers. The Sun's diameter is 1,392,700 kilometers, about 400 times larger, but the Sun is also approximately 400 times farther away from Earth than the Moon. This ratio, the coincidence of size and distance, means that from the surface of the Earth, both objects appear to be nearly exactly the same angular size in the sky. Each one subtends roughly half a degree of arc. This is not something that happens in most solar systems. It is, as far as we know, a coincidence of orbital mechanics and geological timing unique to this moment in Earth's history. The Moon is slowly drifting away from Earth, a few centimeters every year, pulled outward by the same tidal forces it exerts on the oceans below. Billions of years from now, it will be too small in the sky to cover the Sun completely. The window for total solar eclipses is open right now. It will not always be. But right now, in this century, in this era of human observation, the geometry is exact. And on April 8th, 2024, it was demonstrably, measurably, scientifically exact. You are still standing in that field in Texas. It is now 12:23 in the afternoon. Through your eclipse glasses, the circle of the Sun is no longer perfect. There is a small dark notch cut into its upper right edge, a bite taken out of the Sun. The Moon has begun to cross the solar disk. This is called first contact, the moment the Moon's limb first touches the apparent edge of the Sun. Astronomers calculate first contact to within seconds using orbital mechanics and precise ephemeris data. The predictions are accurate to better than 1 second across centuries. The notch grows. This phase, the partial phase, will last approximately 1 hour and 15 minutes at your location. The Moon will move steadily across the face of the Sun, covering it from one edge to the other, but nothing dramatic will happen yet. The sky will remain blue. The temperature will be comfortable. You could almost forget what is coming. This is one of the stranger properties of the human visual system. The eye adapts so efficiently to gradual changes in light that even when the Sun is 70% covered by the Moon, the day still appears reasonably bright. The sky does not look dim. It looks slightly wrong, a shade of blue that is not quite right, with shadows that fall a little too sharply, but not dark. Your brain does not register the loss unless you know what to measure. Out on the field, someone sets down their eclipse glasses and looks at the ground. They have noticed something. Dozens of small crescents are appearing in the grass, not from any direct light source, from the spaces between leaves in the tree above. Each gap in the canopy is acting as a pinhole camera, projecting an inverted image of the partially covered Sun onto the surface below. You look down, there are hundreds of them, tiny crescent suns scattered across the dirt and grass like the symbols from an ancient alphabet. Each one is a real image of the real Sun, reduced and inverted, and scattered at your feet. The light is wrong, the shadows are wrong, something is coming. It is now 1:36 in the afternoon. You have 22 seconds. What happens in the next 4 minutes and 27 seconds at your location is documented in scientific literature, in field reports, in atmospheric measurements from balloon arrays, in radio wave data collected from amateur operators across 6 time zones, and in the memories of approximately 32 million people who stood inside the path of totality. It begins with the temperature. The drop is measurable before the darkness. As the moon covers the last 10% of the solar disk, the infrared radiation reaching the surface decreases sharply. The air closest to the ground cools faster than the air above it, producing a brief thermal inversion. Wind patterns shift. A noticeable breeze rises, moving outward from the center of the shadow's path, what meteorologists call the eclipse wind, generated by the rapid cooling of air within the shadow's footprint. You feel it on your arms before you see the shadow. Then the shadow arrives. It comes from the west, moving at 2,500 kilometers per hour, faster than sound, and it is not darkness the way a room goes dark when you turn off a light. It is a dimensional darkness. It has a visible edge. The horizon to your west turns a deep indigo, the color of the sky at nautical twilight, while the horizon to your east is still pale and bright. You are standing at the boundary of 2 different light environments. One is daytime, one is something else entirely. And then it is over your head. The eclipse glasses come off. The sun is gone. In its place is a black circle, the moon's disk, perfectly circular, unlit, its surface invisible. Around it, extending outward in all directions to a radius of several solar diameters, is the corona. The corona? You have seen photographs. You have seen simulations, but the photographs do not show you the dimension. The photographs do not show you that the corona is not a flat ring around a flat disk. It is a 3-dimensional structure extending away from the sun in all directions, and from where you are standing on the surface of the Earth, you are looking straight down its axis. The streamers extend outward with a delicacy that suggests fine silk or the wisps of exhaled breath on a cold morning. But each one of those streamers is millions of kilometers long, composed of plasma heated to temperatures above 1 million degrees Celsius. You are looking at the atmosphere of a star. The corona is one of the most scientifically puzzling structures in the solar system. The surface of the sun, the photosphere, has a temperature of approximately 5,500 degrees Celsius. As you move away from the surface, through the chromosphere and into the corona, you would expect the temperature to decrease. Energy diminishes with distance. This is basic thermodynamics. Instead, the temperature increases by a factor of several hundred. The corona, which begins at roughly 2,000 kilometers above the photosphere and extends outward for millions of kilometers into space, reaches temperatures between 1 million and 3 million degrees Celsius. In particularly active regions, it can exceed 10 million degrees. The mechanism by which the photosphere, a relatively cool surface compared to the inner layers, heats the corona above it to these extreme temperatures has no fully accepted explanation. This is called the coronal heating problem. It has been formally recognized in solar physics since the 1940s, when Swedish astronomer Bengt Edlund identified the spectral lines of highly ionized iron in the corona and calculated that the temperatures required to ionize iron to that degree were well above 1 million degrees. The observation was initially doubted. It contradicted what physics predicted should happen. It still does not have a complete explanation. And yet there it is above you, white, streaming, impossibly hot, 1 million degrees of unanswered question, visible to the naked eye for 4 minutes and 27 seconds. The leading current hypotheses involve two mechanisms. The first is wave heating, sometimes called Alfvén wave dissipation, a process in which magnetohydrodynamic waves generated by convective motion beneath the photosphere propagate upward through the magnetic field lines and deposit their energy as heat in the corona. The second is nanoflare heating, a theory developed largely by solar physicist Eugene Parker in the 1980s, which proposes that the corona is continuously heated by millions of tiny magnetic reconnection events, each releasing a small burst of energy occurring constantly across the sun's surface. Both mechanisms likely contribute. Neither fully accounts for all observations. You stand in the shadow of the moon and you look at the corona, and you are looking at a problem that the best solar physicists in the world have not yet solved. There is something quietly extraordinary about that, not frightening, just honest. The universe keeps its own schedule, science moves toward it. The corona you are looking at right now, on April 8th, 2024, is not the corona of any previous eclipse. It is different from the corona observed during the 2017 total solar eclipse that crossed the continental United States. It is more complex, more turbulent, more structurally elaborate. The reason is the solar cycle. The sun's magnetic activity follows an 11-year cycle. At solar minimum, the magnetic field is relatively simple and organized. Large polar field lines dominate, and the corona tends to appear symmetrical, with long, thin streamers extending outward from the equatorial regions and relatively quiet polar zones. At solar maximum, the magnetic field becomes disordered and intensely active. Sunspots increase in number and migrate toward the equator. Coronal mass ejections become more frequent. The corona develops complex asymmetrical structures, loops, plumes, and helmet streamers extending in multiple directions at once. The April 8th, 2024 eclipse occurred very close to solar maximum for solar cycle 25. The sun's sunspot count had been climbing steadily since the cycle began at solar minimum in December 2019. What this meant for observers was a corona unlike anything visible in the previous eclipse 7 years earlier. In 2017, the corona was subdued and elegant, a few long equatorial streamers, clear polar plumes. In 2024, the corona was complex and alive-looking. Multiple bright streamers extended outward in all directions. Active regions near the sun's limb showed bright loops of coronal plasma anchored to sunspot groups below. Pink prominences, arcs of cooler, denser plasma suspended above the chromosphere by magnetic field lines, were visible at the edges of the lunar disk with the naked eye. Pink at the edge of the moon's black circle. Real plasma, real magnetism, real fire. The team at Predictive Science Incorporated in San Diego had been running a continuous computational model of the corona for 3 weeks before the eclipse, using real-time magnetic field data from NASA's Solar Dynamics Observatory to update their simulation as new observations arrived. Their final prediction was published minutes before first contact. It captured many of the major streamers correctly, but the sun's activity near solar maximum was changing too rapidly for any model to be perfect. Eruptions on the sun's far side, invisible until they rotated into view, changed the magnetic topology in ways no simulation could fully anticipate. The eclipse humbled the models, and the data it produced will refine them for years. You are still standing in the field. The shadow is over you. You have been looking at the corona for perhaps 90 seconds. Your eyes have adjusted. The brightest stars and planets have emerged in the darkened sky around the sun. Venus, normally invisible in daylight, is visible to the lower right of the eclipsed sun as a bright, steady point of light. Jupiter is visible further away. You are looking at the solar system, seeing multiple worlds at once in a sky that is neither day nor night. The horizon in every direction glows with the deep orange of sunset, but it is not one sunset. It is a 360-degree sunset, a complete ring of atmospheric twilight surrounding the shadow above you. You are standing inside the cone of the moon's shadow, the umbra, and every direction you look toward the edge of that cone, you are looking towards sunlit sky. The umbra is moving beneath you. Even as you stand still, the ground is rotating with the Earth at roughly 1,460 kilometers per hour at this latitude, and the moon's shadow is sweeping northeast at 2,500 kilometers per hour. The geometry is closing. You have 2 minutes and 40 seconds remaining. Let your breath slow with that thought. The corona is still above you, the air is still cool, the field around you is quiet. In a few minutes the light will return and the ordinary day will reassemble itself. The blue sky, the warmth, the long familiar brightness of a Texas afternoon. The birds will come back out, the temperature will rise, the shadow will be gone. But right now it is here. And the universe is exactly what it is. Let that settle. Let your body rest in it. The corona streams outward above you, carrying the solar wind with it, a continuous flow of charged particles accelerating outward from the sun's atmosphere into the wider solar system. The solar wind does not stop at Earth. It continues outward past every planet, across billions of kilometers, until it finally runs out of pressure to push against the interstellar medium. That wind began its journey in the corona you are looking at right now. One continuous flow from this fire across the whole solar system. Rest now. The shadow holds you. The corona burns above you, 1,000,000 degrees and completely silent, its light crossing 150 million kilometers to reach the field where you are standing. Let your muscles go soft. The next part of this story takes you deeper into the structure of the sun itself and into what the corona was telling scientists on April 8th that they had never been able to hear before. But there is no hurry. The shadow is still here. And so are you. Rest. The shadow is still with you. You have not moved. The field around you is quiet, the air still cool, and above you the corona continues to stream outward from the black disk of the moon in every direction. The corona is not static. On a time scale of minutes, it would be difficult to detect the movement with the naked eye, but instruments measuring in seconds see the corona breathing, shifting slowly like smoke in a windless room, driven by the continuous movement of magnetic field lines threading through the sun's outer atmosphere. You are watching a dynamic structure. It only appears still. Let that image rest behind your eyes, the corona. White, outward, silent from here. Before we go deeper into what scientists measured on April 8th, it is worth understanding what the sun actually is, not in a general sense, but in the specific, physical, measurable sense that solar scientists work with every day. The sun is a sphere of plasma with a diameter of 1,392,700 kilometers. Its mass is approximately 1.989 times 10 to the power of 30 kilograms, a number so large it contains roughly 99.86% of all the mass in the solar system. The 8 planets, the dwarf planets, the asteroid belt, the Kuiper belt, all the moons and comets and dust, all of that combined accounts for less than 1/5 of 1% of the solar system's total mass. Everything else is the sun. At the sun's core, which extends from the center to roughly 25% of the solar radius, the temperature reaches approximately 15 million degrees Celsius. At this temperature and density, about 150 times the density of water, hydrogen nuclei move fast enough and close enough together that quantum tunneling allows them to overcome their mutual electromagnetic repulsion. 2 hydrogen nuclei fuse into deuterium. Through a series of subsequent reactions, deuterium and additional hydrogen nuclei eventually produce helium-4, releasing energy in the process. This process is called the proton-proton chain, and it generates virtually all of the sun's energy output. Every second, the sun converts approximately 600 million metric tons of hydrogen into helium. In doing so, roughly 4 million metric tons of matter is converted directly into energy. In accordance with Einstein's equation, mass times the square of the speed of light. 4 million metric tons of mass transformed into the electromagnetic radiation that lights and warms everything you have ever known, every second, without interruption. The sun has been doing this for approximately 4.6 billion years. It has enough hydrogen remaining to continue for approximately another 5 billion years. You are standing beneath something ancient and continuous. It has been burning since before Earth had oceans. The energy produced at the sun's core does not travel easily to the surface. The interior of the sun is so dense that a photon, a particle of light generated at the core, will take between 10,000 and 170,000 years to work its way out to the surface, constantly absorbed and re-emitted by the dense plasma through which it passes. This region, from the core outward to roughly 70% of the solar radius, is called the radiative zone, and transport through it is governed by radiation diffusion, slow, repeated absorption and emission events that cause the photon to execute a random walk outward. At 70% of the solar radius, the plasma becomes cool enough and dense enough that convection takes over. Hot plasma bubbles up from below, cools near the surface, and sinks back down. This churning region is the convective zone. The convective cells at the sun's surface, called granules, are typically 1,000 kilometers across and have lifetimes of about 10 minutes. A typical granule rises at the center, spreads outward, cools, and sinks at its edges. The surface of the sun, seen in high-resolution solar telescope imagery, looks like an endlessly churning mosaic of bright, short-lived cells separated by darker intergranular lanes. This convection is also responsible for generating the sun's magnetic field. As the plasma rotates differentially, faster at the equator, slower at the poles, and as the convective motion carries charged particles upward and downward, electrical currents form. Those currents generate magnetic fields. The fields are amplified by the differential rotation, stretched and twisted and eventually brought to the surface, where they emerge as sunspots, regions where the magnetic field is so concentrated that it inhibits convection, allowing the plasma to cool slightly. Sunspots are typically 3,500 to 4,500 degrees Celsius, cooler than the surrounding photosphere, which is why they appear dark by contrast, though a sunspot isolated in space would glow brightly. The corona above you is threaded through with these magnetic fields. Every streamer, every loop, every plume is following a field line. The corona does not distribute itself randomly. It is structured by magnetism, organized by forces that emerge from convection thousands of kilometers below the surface. What you see when you look at the corona is magnetism made visible. Above your field in Texas, the corona extends outward in several distinct structural zones. The innermost corona, closest to the sun's surface, is called the K corona, from the German word continuum. The K corona is formed by sunlight scattered off free electrons in the coronal plasma. It is the brightest part of the corona and extends to roughly 2 or 3 solar radii from the sun's center. The scattering of photons by fast-moving electrons causes a slight broadening and blurring of the solar spectral lines, which allows scientists to distinguish K corona light from other sources. Beyond the K corona is the F corona, from Fraunhofer, referring to the absorption lines visible in the spectrum of sunlight scattered off dust particles in the solar system. The F corona is caused not by electrons in the solar atmosphere, but by interplanetary dust concentrated near the sun's vicinity. It extends much farther from the sun and gradually merges with the zodiacal light, the faint, diffuse glow visible along the plane of the solar system on very dark nights. Beyond both of these, the extended corona transitions into the solar wind, the continuous outflow of charged particles that fills the solar system. During the April 8th eclipse, ground-based observers and aircraft-mounted instruments focused primarily on the inner corona, out to about 3 or 4 solar radii. This is the region where the solar wind is still being accelerated, where the plasma is making the transition from the sun's gravitational influence to the outward flowing stream that crosses the entire solar system. Understanding how the wind accelerates in this zone is one of the central unsolved problems in heliophysics. NASA's Parker Solar Probe, which has been making increasingly close passes to the sun since 2018, is designed to measure this region directly, but the eclipse provided something different: a wide-field, simultaneous view of the entire inner corona at once, from multiple instruments at different locations along the path of totality. Parker sees one small region at a time, up close from inside. The eclipse showed the whole structure at once, from outside. Both views are necessary. You are standing in the shadow still, though your minutes are running short. Look at the corona again, not as a spectacle, as a question. There is a specific feature visible in the corona above you tonight, above you in April 2024 near solar maximum, that would not have been visible in the same way in 2017. There are structures called helmet streamers, extending outward from the equatorial regions of the sun. They are so named because, in profile, they resemble the visor of an old medieval helmet, a bulging bright base tapering into a long, narrow streamer, extending radially outward. Helmet streamers form where closed magnetic loops in the low corona trap dense plasma. The plasma accumulates, becomes denser and brighter, and the loops are stretched outward by the solar wind until they elongate into the characteristic streamer shape. At the tip of the streamer, where the magnetic field lines cannot hold the plasma indefinitely, small plasmoids, blobs of magnetized plasma, are pinched off and carried outward by the solar wind. These disconnection events are tiny compared to a coronal mass ejection, but they are continuous. The sun is always losing mass this way, not in a sudden eruption, but in a slow, constant shedding at the tips of its streamers. Near solar maximum, The streamers are more numerous, more prominent, and more variable. The corona on April 8th showed streamers extending outward in several directions, not just the equatorial streamers typical of solar minimum, but active region streamers anchored above sunspot groups at higher latitudes. Instruments mounted on NASA's WB-57 high-altitude research aircraft, which flew at 50,000 feet along sections of the Eclipse path to extend their observation time, collected coronal emission line data that will take months to fully analyze. Preliminary results presented at the American Geophysical Union meeting in December 2024 confirmed multiple active region contributions to the corona's structure, consistent with near maximum conditions. Every streamer above you has a name, a position, a spectrum. Nothing is decoration. There is one more structure you should know about before the shadow leaves. At the edge of the black lunar disk, the boundary between the moon and the corona, look carefully. There, almost too pink to be real, against the white of the corona, are the prominences. A prominence is a region of relatively cool, dense plasma, typically around 10,000 degrees Celsius, compared to the million-degree corona surrounding it, suspended above the photosphere by magnetic field lines. It is, in a sense, a thread of chromospheric material held up in space by magnetism, insulated from the much hotter corona above and below it. Prominences can persist for weeks or months, slowly evolving as the magnetic field that supports them shifts. In photographs and observations from April 8th, prominences were visible along multiple points of the lunar limb, glowing a distinctively reddish-pink color that results from hydrogen emission at the H-alpha wavelength of 656.3 nanometers. This emission is produced when hydrogen electrons drop from the third energy level to the second, releasing a photon of that specific wavelength. You are watching individual hydrogen atoms emit light at a precise measurable energy. Multiplied by trillions upon trillions of atoms, the sum of those emissions becomes the pink glow at the moon's edge. Every color in science has a number. Every glow has a mechanism. The pink at the moon's edge is hydrogen, 656 nanometers, falling from n=3 to n=2. Real atoms, real transitions, real light. Nonessy. Your time in the shadow is nearly over. The corona has been visible for 4 minutes and 21 seconds. In 6 more seconds, the leading edge of the sun, the limb, will appear. When it does, it will appear as a single point of overwhelming light, a phenomenon called the diamond ring effect. The first photons from the photosphere, emerging through a valley on the moon's irregular surface, concentrated into a single brilliant point against the remaining glow of the inner corona. You look away before it happens. You have already put on your eclipse glasses. There is a flash, and then the sun is back. Not the corona, not the diamond ring. The sun, the ordinary, familiar, slightly overwhelming sun, filling the sky with its photosphere radiation at an irradiance of approximately 1,361 watts per square meter at the top of Earth's atmosphere. The temperature rises quickly. Within minutes, the eclipse wind reverses. The birds come back, the grass brightens, people around you are laughing, some of them crying, embracing strangers. Someone is calling a family member who watched from 2 states away. But you are quiet. You are thinking about the corona, about how it is still there, still burning at 1,000,000 degrees, still streaming outward, still carrying the solar wind into the solar system. You cannot see it now because the photosphere is too bright, but it has not gone anywhere. The corona is always there. You simply cannot see it without the moon's help. It is there right now, above the blue sky, above the clouds, 1,000,000 degrees, streaming outward every day. Let that image stay with you as the daytime settles back around you. The 32 million people who stood inside the path of totality on April 8th, 2024, were spread across a strip of land roughly 12,000 kilometers long and never more than 185 kilometers wide, from the Pacific coast of Mexico to the Atlantic coast of Newfoundland. They came from different states, different countries, different scientific backgrounds. Some were professional astronomers with instruments worth hundreds of thousands of dollars. Some were children seeing their first eclipse. Some drove 12 hours to be inside the path. What they all shared, for 4 to 5 minutes depending on location, was the same geometry, the same alignment, the same shadow. The physics was identical for all of them. Atmospheric scientist teams from university research groups released weather balloons at 1-hour intervals for 30 continuous hours across the path, measuring changes in atmospheric pressure, humidity, and temperature at multiple altitudes as the shadow approached, passed, and departed. The data showed consistent atmospheric gravity waves generated by the rapid thermal change, ripples in the atmosphere caused by the sudden cooling and reheating, similar to the gravity waves generated by a thunderstorm or a mountain range, but occurring on a continental scale and lasting only minutes. More than 6,350 amateur radio operators across the United States participated in a separate study of the eclipse's effect on the ionosphere, the electrically charged layer of the upper atmosphere that extends from roughly 60 to 1,000 kilometers altitude. Radio signals bouncing off the ionosphere were monitored before, during, and after the eclipse by stations across 6 time zones, generating a real-time map of how the ionospheric plasma changed as the shadow crossed. The temporary removal of ultraviolet and X-ray radiation from the sun during totality allowed the ionosphere's charge to partially dissipate, altering the height and density of the reflective layer, changing the behavior of radio waves that depended on it. The eclipse was not just a visual event, it was a planetary event. For 90 minutes, a moving shadow reshaped the electromagnetic environment of the atmosphere over an entire continent. The air changed, the ions changed, the radio waves changed, all from the moon moving in front of the sun. You are no longer standing in the Texas field. The afternoon has passed, the sun has set as it always does, and the sky outside is dark. You are lying down now. The temperature in the room is comfortable. Your breathing has slowed without you deciding to slow it. This is normal. Your body does this when you are at rest, when the signals from the environment are calm and consistent and unthreatening. Your heart rate has settled into its resting rhythm. Your muscles are releasing the small tensions they carry through the day. You do not need to do anything with this information. You just need to know that it is happening, that your body knows how to do this, that the transition towards sleep is already in motion, the way the moon was already in motion hours before the shadow arrived. Processes that look sudden are often long in preparation. The corona was always above the photosphere. The shadow was always coming. Your rest has been coming for hours. Let it arrive. Outside, above the atmosphere, the solar wind is flowing. The corona is burning. The same hydrogen atoms that were emitting H-alpha light at the moon's edge this afternoon are still emitting it now, in a continuous cycle of excitation and emission that has been ongoing since the sun formed. The sun does not sleep, but you can. In the next part of this story, we will go further into what happens to the solar wind after it leaves the corona, and how the instruments on Parker's solar probe, designed for that boundary zone between the sun and space, have changed what we understand about the structure of the inner heliosphere. There is no hurry. For now, the field in Texas is quiet. The corona is invisible behind the blue sky of the other side of Earth. The moon has moved on, continuing its orbit, and the shadow it cast has long since dissolved into space. Everything is in its orbit, moving exactly as it has always moved. Rest now. You are very still. And the universe continues, exactly as it always has, in every direction from where you are lying. Sleep. The corona is still burning. You cannot see it from where you are lying. The atmosphere above you, the curvature of the Earth, the long rotation of the planet away from the sun, all of these things stand between you and that white streaming fire, but none of them have changed what the corona is. It is still there, at the same temperature, releasing the same particles, driving the same wind outward through the solar system. Distance does not change what a thing is. Let that thought rest with you for a moment. Something 150 million kilometers away is happening right now, continuously, and it has been happening every second of your life without interruption. The corona was burning when you were born. It was burning before your parents were born. It was burning before any human being was alive to notice it. And yet on April 8th, 2024, for 4 minutes and 27 seconds in central Texas, you could see it with your own eyes. That is what the moon gave you. Let your breath slow. We are going further now. In December of 2024, NASA's Parker Solar Probe completed its closest approach to the sun in the mission's history. It flew within 6.1 million kilometers of the solar surface, closer than any human-made object had ever traveled to a star. At that distance, the probe was moving at approximately 692,000 kilometers per hour, making it the fastest spacecraft ever built at the time of that record. The speed is not arbitrary. It is a consequence of orbital mechanics. As an object falls toward the sun, it accelerates. Parker's solar probe uses repeated gravitational assists from Venus to gradually lower its perihelion, its closest point, and with each successive pass, it falls a little deeper into the sun's gravity well, moving a little faster. At 6.1 million kilometers, the probe was inside the corona, not observing it from the outside, the way eclipse watchers do from the surface of Earth. Inside it, moving through it, sampling the plasma directly, measuring the magnetic field, recording the density and temperature and velocity of individual charged particles as they streamed past the spacecraft. The corona at that distance is not the delicate white veil you saw from Texas. It is a hot, low-density plasma moving outward at hundreds of kilometers per second, threaded through with magnetic structures that twist and fold as they are carried away from the sun. Parker's solar probe has sensors for all of it. The field's instrument suite measures the electric and magnetic fields in the corona with high precision and time resolution. The solar wind electrons alphas and protons instrument, SWIPE, measures the velocity distribution, density, and temperature of the major particle species in the solar wind. The Integrated Science Investigation of the Sun, ISIS, measures energetic particles accelerated by solar events. And the Wide Field Imager for Parker's Solar Probe, SPIR, takes images of the corona and inner heliosphere in visible light, allowing direct imaging of plasma structures from inside the region being imaged. This is like being inside a weather system and photographing it at the same time. One of Parker's Solar Probe's most significant early discoveries, published in 2019, early in the mission, was the detection of what researchers called switchbacks. A switchback is a sudden, brief reversal in the direction of the magnetic field carried by the solar wind. As the solar wind flows outward from the sun, the magnetic field lines embedded in it spiral gradually outward in what is called the Parker spiral, a pattern predicted by Eugene Parker in 1958 and confirmed by subsequent observations. The field lines trail behind the sun's rotation, wrapping into a large Archimedean spiral that fills the inner solar system. Parker himself predicted the solar wind and its magnetic structure before any spacecraft had directly measured it. His predictions were initially dismissed. When the first direct measurements arrived from NASA's Mariner 2 spacecraft in 1962, they confirmed not just the existence of the solar wind, but much of the structure Parker had mathematically described. He was eventually awarded the Nobel Prize in Physics in 2017 at the age of 89, the first living person to see a spacecraft launched in their own name. Parker's Solar Probe is named for him, and it is that spacecraft which, flying through the inner corona Parker theorized about for decades, discovered that the magnetic field there does not smoothly spiral outward as expected at closer distances. Instead, it folds back on itself repeatedly, brief reversals, lasting seconds to minutes, where the field direction suddenly flips and then returns to its original orientation. These switchbacks were detected on nearly every orbit. They are now understood to be a significant feature of the near-Sun solar wind, not an anomaly, and their origin is still actively debated. Some researchers link them to magnetic reconnection events low in the corona, the same process implicated in coronal heating. Others propose they form through velocity shear, as faster and slower streams of solar wind interact. The closer you look at the sun, the more questions appear. The corona you observed from Texas is connected directly to the solar wind, Parker's Solar Probe, measured 6 months later. The streamers you saw extending outward, the helmet streamers, the active region plumes, these are the sources. The solar wind does not flow uniformly from the entire solar surface. It comes from specific regions, and its speed and density depend on where it originates. Fast solar wind, typically moving at 600 to 800 kilometers per second by the time it reaches Earth's orbit, comes primarily from coronal holes. Coronal holes are regions where the magnetic field is open to space, where field lines extend outward without looping back to the surface. In these regions, plasma can escape freely, and it does so quickly. In ultraviolet and X-ray images of the sun, coronal holes appear darker than surrounding regions because the plasma there is less dense and cooler. Slow solar wind, typically 300 to 500 kilometers per second, comes from regions near the edges of helmet streamers and from boundaries between open and closed field line regions. Its exact origin has been debated for decades. Some of it appears to originate from the tips of helmet streamers, where plasma is slowly released as plasmoids pinch off. Some appears to come from narrow bands of open field lines, threading through otherwise closed field regions. Parker's solar probe has begun to constrain these origin questions by measuring the properties of the solar wind close enough to the sun that the streams have not yet been mixed and homogenized by their journey outward. The chemical composition of the wind, the relative abundances of different elements, the ratio of certain isotopes, acts as a fingerprint that can be traced back to the source region on the sun. On April 8, 2024, when ground-based observers were measuring the corona's structure in visible light, Parker's solar probe was in a different part of its orbit, farther from the sun, monitoring the solar wind in the inner heliosphere. The two observations, the wide-field eclipse view from Earth and the in-situ measurements from the spacecraft, are complementary in a way no single instrument can replicate. You need the bird's eye view, and you need to be inside it. Take a breath. There is no rush here. The room around you is dark and still. Whatever sounds exist outside, traffic, wind, the small sounds of a building at rest, they have faded into background. Your body is warm and heavy in a comfortable way. Your eyes have been closed for a while now, or nearly closed. The images behind them are loose and drifting. The corona, the streamers, the edge of the moon's disk. Let them drift. You do not need to hold on to the science. It is already in you. The facts have a way of settling in, finding their weight, becoming part of the quiet context in which the mind rests. The solar wind is flowing right now. About 1 million tons of mass leaves the sun every second through this continuous outflow, though the sun is large enough that it will lose less than 1/10 of 1% of its mass in the time remaining before it becomes a red giant. The loss is real and measurable. It is simply inconsequential on the timescales relevant to any living thing. The wind travels at different speeds depending on where it originated. Fast streams from coronal holes, slower streams from the edges of helmet streamers. But in all cases, it takes roughly 2 to 4 days to reach Earth from the sun. The light you see from the sun is 8 minutes old when it reaches you. The solar wind you are currently immersed in, the tenuous stream of charged particles surrounding Earth right now, left the sun 2 to 4 days ago. You are not just near the sun's influence, you are inside it. The boundary of the heliosphere is 120 astronomical units from the sun, and Earth orbits at 1. You are as much inside the sun's extended atmosphere as a person standing inside a large building is inside the building. The corona does not end at its visible edge. It continues outward as the solar wind, all the way to where Voyager 1 now travels, in true interstellar space. In 2021, using data from Parker Solar Probe's 8th perihelion pass, a team of researchers confirmed that the spacecraft had, for the first time, passed through the Alphen critical surface. The Alphen critical surface, sometimes called the Alphen point, is the boundary beyond which the solar wind is moving faster than the Alphen speed, the speed at which magnetic waves can propagate back toward the sun against the outflowing plasma. Inside the Alphen surface, magnetic waves generated in the corona can propagate back toward the photosphere, meaning the solar atmosphere is still causally connected to the sun. Beyond it, the outflow is supersonic in the magnetohydrodynamic sense, and no information can travel back upstream. The solar wind, beyond this point, is truly launched and traveling alone. Parker's solar probe crossed this boundary and then recrossed it multiple times on the same pass. The surface is not a fixed sphere, but a wrinkled, dynamic structure that moves inward and outward as conditions in the corona change. The spacecraft dipped inside the Alphen surface for brief periods, then returned to outside it, giving researchers their first direct glimpse of the transition zone between the bound corona and the free-flowing solar wind. This is where the corona ends. Not sharply, not at a single defined altitude, but gradually across a dynamic shifting boundary, the sun's atmosphere releases its grip on the plasma and lets it go. The solar wind begins there. Beyond that line, the plasma belongs to the solar system. Before it, it still belongs to the sun. Morno, you are very still now. The solar wind that passed through the Alphen surface near the sun 2 or 3 days ago is now streaming past Earth. Some of it is captured by Earth's magnetic field, the magnetosphere, which deflects most of the solar wind around the planet and compresses on the sunward side to a boundary roughly 10 Earth radii from the surface. On the night side, the magnetosphere stretches out into a long tail, hundreds of Earth radii downstream, shaped by the constant pressure of the solar wind flowing past. This is the magnetosphere you live inside. You have lived inside it every day of your life, though you have never felt it directly. The magnetic field it generates protects the atmosphere from the sustained erosion that would otherwise strip lighter molecules away, a process that may be responsible for Mars having lost most of its original atmosphere after its planetary magnetic field weakened and eventually ceased roughly 4 billion years ago. Earth's magnetic field is generated by the movement of molten iron in the outer core, roughly 2,900 kilometers below your feet. A convecting iron, liquid metal in slow, complex circulation patterns, generates electrical currents, and those currents produce the magnetic field that deflects the solar wind. The field is not perfectly aligned with Earth's rotation axis. The magnetic North Pole is offset by approximately 11 degrees from the geographic North Pole, and it drifts slowly over time. It has moved roughly 55 kilometers per year recently towards Siberia as the circulation patterns in the core shift. The magnetosphere is not static. It breathes with the solar wind. When a coronal mass ejection, a large eruption of magnetized plasma from the sun, reaches Earth after a journey of 1 to 3 days, it compresses the magnetosphere on the sunward side, sometimes pushing it inside the orbit of geostationary satellites. The energy deposited into the magnetosphere drives geomagnetic storms, induces currents in long electrical conductors at the surface, and produces auroras visible far from the poles. During the week of April 8th, 2024, the sun was near solar maximum. The eclipse itself was not accompanied by a major coronal mass ejection at Earth. The corona you observed was active but not eruptive at that moment. But in the months surrounding the eclipse, the sun produced several X-class flares and associated particle events, consistent with the heightened activity of the solar maximum period. The eclipse was one frame of a larger story. The sun does not pause for observation. No one. The night outside is deep now. Somewhere above the atmosphere, electrons and protons are streaming past, deflected around the planet's magnetic bubble, most of them never reaching the surface. The aurora borealis is glowing along the northern oval, where magnetic field lines converge and channel energetic particles down into the upper atmosphere at an altitude of roughly 100 to 300 kilometers. Those particles collide with oxygen and nitrogen atoms, exciting them to higher energy states. When the atoms relax back to their ground state, they emit light, green at the most common altitudes, from oxygen releasing energy at 557.7 nanometers, red at higher altitudes, from oxygen at 630 nanometers, blue and purple from nitrogen. The aurora is visible tonight. You cannot see it from here, but it is there, somewhere to the north, rippling in curtains of green and red against the dark sky, driven by the same solar wind that originated in the corona you watched on April 8th. The light from the aurora and the light from the corona are connected by physics. Both are the sun expressing itself through different intermediaries. The sun's energy transformed, traveling, arriving. Let that journey carry you now. Morgens prantinetum. Your breathing is slow and even. The body has its own rhythm, separate from thought, and at rest it settles into that rhythm without effort. 12 to 16 breaths per minute at full rest. Each breath draws approximately half a liter of air, a mix of nitrogen, oxygen, argon, carbon dioxide. The oxygen is extracted by the alveoli in the lungs and transferred to hemoglobin in the red blood cells, which carry it to every cell in the body. The energy those cells produce through the oxidation of glucose in mitochondria is ultimately solar energy. The glucose comes from food, which comes from plants, which built it from carbon dioxide and water using sunlight. The energy in your body right now is the sun, transformed twice over, resting quietly in the tissues of a living thing. You're made of the sun's output. Not metaphorically, energetically, the calories that warm you and move you and keep your heart beating were once photons crossing 150 million kilometers of space. The corona above Texas, the solar wind past the Alvan surface, the aurora in the north, the warmth in your cells, one source, one continuous output, carried in different forms across unimaginable distances to arrive, finally, quietly here. Rest in that. There is no effort required. The sun did the work. Your body received it, stored it, and is now releasing it slowly as warmth and breath and the quiet electrical activity of a brain at rest. That journey is the next part of this story, the solar wind moving outward across the full width of the solar system, carrying the corona's fingerprint all the way to the boundary of interstellar space. For now, there is only the quiet. The aurora somewhere to the north, the solar wind streaming past, the magnetosphere holding its shape around the planet, and you inside all of it, already nearly asleep. Rest. You are still here. The room is quiet. The night has deepened. Whatever small sounds existed before, a distant car, the settling of a building, the faint noise of wind, have merged into a low continuous background that your brain no longer bothers to process individually. This is what the auditory system does at rest. It filters. It decides what is signal and what is landscape, what requires attention and what simply is. You are the listener. The universe is the landscape. And tonight, the landscape stretches all the way to the edge of the solar system. Let your body stay where it is. We are going to move outward. Darse, 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 darse. The solar wind that left the corona, the one you watched from Texas, streaming outward through the Alvan surface, past Earth, does not stop at Earth. It continues. Past the orbit of Mars at 1.52 astronomical units from the Sun, past the asteroid belt, past the orbit of Jupiter at 5.2 astronomical units, where the solar wind has already been flowing for roughly 2 weeks since it left the corona, past Saturn at 9.5 astronomical units, past Uranus and Neptune at 19 and 30 astronomical units respectively. The solar wind at Neptune's distance has been traveling for roughly 4 months. Its density has thinned enormously by then. Particles that left the sun in a dense hot stream have spread out across an expanding sphere, and the density falls off as the inverse square of the distance. At Neptune, the solar wind density is roughly 10,000 times lower than it is at Earth's orbit. But it is still there, still flowing, still magnetized. This entire region, from the sun to the outermost boundary of the solar wind's influence, is called the heliosphere. It is not a perfect sphere. The solar wind does not flow uniformly in all directions, and as the solar system moves through the local interstellar medium, the heliosphere is compressed on the side facing the direction of travel and stretched out into a long tail behind it. The shape is roughly analogous to the magnetosphere, a blunt bow facing the interstellar wind, a long downstream wake. The boundary of the heliosphere has 2 distinct zones. The first is the termination shock, the region where the solar wind, still supersonic, abruptly slows as it encounters resistance from the surrounding interstellar medium. At the termination shock, the solar wind decelerates from supersonic to subsonic speeds within a relatively short distance. Voyager 1 crossed the termination shock in 2004 at a distance of approximately 94 astronomical units. Voyager 2 crossed it in 2007 at approximately 84 astronomical units, the difference reflecting the asymmetry of the heliosphere. Beyond the termination shock is the heliosheath, a region of hot, compressed, turbulent plasma, where the slowed solar wind piles up and moves in complex, disordered patterns before finally reaching the outer boundary. That outer boundary is the heliopause. Nursa. The heliopause is where the solar wind stops. It is the surface, again, not a sharp line, but a dynamic, shifting boundary, where the pressure of the solar wind is exactly balanced by the pressure of the interstellar medium. Inside the heliopause, the plasma is predominantly of solar origin. Outside it, the plasma is interstellar. Voyager 1 crossed the heliopause in August of 2012 at a distance of approximately 121 astronomical units from the Sun. Voyager 2 crossed it in November of 2018 at approximately 119 astronomical units. Both crossings were confirmed by a characteristic change in the properties of the plasma. The density increased sharply, the temperature changed, and the magnetic field direction shifted in ways consistent with the transition from heliospheric to interstellar plasma. Beyond the heliopause, both Voyager probes are now in interstellar space, the first human-made objects to have left the Sun's extended atmosphere and entered the medium between the stars. The particles they are detecting now are not from the Sun. They are interstellar cosmic rays, galactic magnetic fields, the diffuse plasma of the space between stellar systems. The corona you watched on April 8th drives a wind that reaches all the way to this boundary. The solar wind is the extended corona, and the extended corona reaches the space between the stars. Tsue saying, "There is something worth sitting with in that fact. On the morning of April 8th, plasma left the corona above the active regions you watched from Texas. It joined the solar wind streaming outward through the inner heliosphere. In 2 to 4 days, it passed the orbit of Earth. In 2 to 3 weeks, it passed Jupiter. In several months, it reached the outer solar system. In years, it will reach the termination shock. In decades, if it survives the crossing of the heliosheath, it will push against the heliopause. Eventually, the mass of the Sun is the mass of the interstellar medium. The boundary is where one pressure yields to another. The wind does not know it is ending. There is no moment of decision. The pressure simply falls below what is required to continue, and the plasma stops moving outward, and it becomes part of something larger. Everything the Sun releases becomes part of the heliosphere, and eventually the heliosphere yields to the galaxy. Nothing is lost, it just changes context. Mayor and Smen, let your attention come back closer now. We are going to stay in the inner solar system for a while, not at the edge, but here, in the region between the Sun and the Earth, in the neighborhood of the corona's immediate influence. One of the phenomena generated by the corona and the solar wind that most people have seen but few have studied is the zodiacal light. The zodiacal light is a faint, diffuse cone of illumination visible in the western sky after astronomical twilight in the evening, or in the eastern sky before astronomical dawn, always extending along the ecliptic, the plane of the solar system. It is most visible from dark sky locations, away from artificial light, and appears as a broad, soft pyramid of light rising from the horizon. It is caused by sunlight scattered off interplanetary dust, a diffuse population of small particles, mostly between 10 micrometers and a millimeter in diameter, distributed throughout the inner solar system in a disk-like structure following the ecliptic plane. This dust originates from multiple sources: comets releasing material as they heat near the Sun, collisions in the asteroid belt, and the gradual disintegration of larger debris. The particles are continuously being removed from the solar system by radiation pressure, by the Poynting-Robertson effect, which causes small particles to spiral slowly inward toward the Sun, and by Jupiter's gravitational influence, which perturbs particles in certain orbital resonances. But the dust is continuously replenished from new cometary and asteroidal sources. The result is a steady-state disk of fine particles that fills the inner solar system, visible from Earth as the zodiacal light. The F corona, the outer part of the corona that appears in eclipse images, is the zodiacal dust seen close to the Sun, where its density is higher and the scattered light brighter. The zodiacal light and the F corona are the same structure, seen at different distances. When you looked at the corona from Texas and saw the outer, softer glow extending beyond the bright K corona, you were looking at sunlight scattered from the same dust particles that create the zodiacal light on dark moonless nights. The inner solar system is not empty. It is filled with moving dust, flowing plasma, and streaming particles, all of it lit by a star at the center. Every dark sky phenomenon connects back to the Sun. There is no part of the solar system that does not carry its light. Timon. Something else was happening on April 8th, 2024, while the eclipse proceeded over North America. Roughly 1.5 million kilometers from Earth, in the direction of the Sun, the Deep Space Climate Observatory, known as DSCO-VR, was observing the eclipse from a different perspective entirely. DSCO-VR orbits the Lagrange point L1, the point between the Earth and the Sun where the gravitational pull of both bodies is balanced, allowing a spacecraft to remain roughly stationary relative to Earth with minimal fuel expenditure. From L1, DSCO-VR monitors the solar wind continuously, measuring the speed, density, temperature, and magnetic field orientation of the incoming plasma before it reaches Earth's magnetosphere. This gives Earth roughly 15 to 60 minutes of warning before solar wind changes, including the arrival of coronal mass ejections, affect the magnetosphere. The SEOVR's Earth Observing Camera, the EPIC instrument, which stands for Earth Polychromatic Imaging Camera, captures images of the fully illuminated Earth once every 1 to 2 hours. On April 8th, it captured a series of images showing the moon's shadow moving across the face of North America, a small dark oval sweeping from the southwest toward the northeast. From space, the eclipse was a shadow on a planet. From inside the shadow, it was a portal into the physics of the sun. Both are true simultaneously. When the rare, your eyes have been closed for some time now. The images behind them, the corona, the streamers, the Voyager probes at the edge of interstellar space, the shadow on the planet is seen from L1. These images have stopped being facts you hold and have started to become the landscape of something closer to dream. This is normal. This is the transition. The brain, moving towards sleep, begins to lose the sharp distinction between image and thought, between what it recalls and what it constructs. The hippocampus, which encodes episodic memory, begins to release its grip. The prefrontal cortex, which governs deliberate thought, quiets. The activity pattern in the brain changes, not stopping, never stopping, but reorganizing. The high-frequency oscillations of waking attention give way to slower rhythms. You do not need to understand this as it happens. You never have. You have been doing it every night of your life. The solar wind is flowing past the planet at 400 kilometers per second. Your breathing continues at its own pace, slow and uncounted. The corona is burning above the far side of the Earth, and you are moving, without effort, toward the place where science becomes landscape and landscape becomes rest. Stay with that. My Aor. The sun's 11-year cycle has a name, the Schwabe cycle, after Heinrich Schwabe, a German amateur astronomer who spent 17 years counting sunspots and in 1843 announced that their number rose and fell with a roughly 10-year period. His claim was initially ignored. He had no explanation for the mechanism, just the observation, built from patient counting over nearly 2 decades. It took further decades for the cycle to be confirmed and accepted by the broader scientific community. The current solar cycle, Solar Cycle 25, began at solar minimum in December 2019. Its activity exceeded predictions made at the start of the cycle. The Solar Cycle 25 prediction panel had forecast a moderate, below-average cycle, and instead it has tracked significantly above their predictions in sunspot numbers and flare activity. Solar Cycle 25's maximum was occurring in late 2024 and into 2025, meaning the eclipse of April 8th, 2024, occurred just as the cycle was approaching its peak. The corona you observed was the most active corona visible from Earth in a total eclipse since at least the 2001 eclipse, which also occurred near solar maximum. Cycle 25 will reach solar minimum again around 2030, and solar cycle 26 will begin. The next total solar eclipse visible from the contiguous United States will be on August 23, 2044. By then, solar cycle 28 will be underway. Whether that eclipse occurs near solar maximum or solar minimum will determine what kind of corona its observers see, simple and elegant, or complex and streaming with structures in every direction. 20 years from now, somewhere in North America, people will stand in a shadow and look up. The corona will be different that day, a different phase of a different cycle, a different configuration of magnetic field lines, new active regions above new sunspot groups. But the physics will be the same proton-proton chain in the core, the same random walk through the radiative zone, the same convection lifting plasma to the photosphere, the same corona heated by processes still incompletely understood, to temperatures that still defy simple explanation. The same mystery waiting in the sky. Nairn Sor. The city outside your window, or the quiet outside it, if you are somewhere without much city, has settled into its nighttime state. The air is cooler, the traffic, if there is any, is sparse and distant. The rhythms of human activity have slowed. This is what night does. It is not simply the absence of sunlight. It is the planet turning away from the source, and everything that depends on that source: plant metabolism, animal behavior, human schedules, temperature gradients that drive weather, all of it adjusting to the reorientation. The dark side of Earth is not separate from the sun. It is just the far side of a relationship that is always ongoing. The magnetosphere continues its interaction with the solar wind. The ionosphere continues its slow recombination. The aurora continues in the polar regions. The corona continues its outflow. The sun does not stop when Earth turns away from it. It simply continues in all directions without distinction. You are on the night side of the planet. You are inside the heliosphere. You are in the extended corona technically, if you define the corona as everything that originated in that hot plasma above the photosphere and has since traveled outward as solar wind. You are inside the sun's atmosphere. You always have been. The corona did not end at the moon's edge. It became the solar wind. And the solar wind reaches all the way to the boundary where the sun's pressure finally yields to the galaxy. You are immersed in it right now. Nairn's one woof. Let that be the last thought that requires effort. The sun's atmosphere is around you. The solar wind flows past the magnetosphere continuously. The aurora glows in the north. The zodiacal dust scatters light along the ecliptic. Parker's solar probe moves through the inner corona. The Voyager probes drift through interstellar space. All of this is happening right now. All of it is real. None of it requires your attention. You have held a large piece of the universe in your mind tonight. The shadow crossing a continent, the corona above a Texas field, the solar wind flowing outward across the solar system to the very edge of the sun's influence. You have stood inside the physics of a total solar eclipse and understood not just what it looks like, but what it means. That is enough. More than enough. Your body knows what to do from here. It has done this every night of your life, reliably, without instruction. The chemistry is already underway. The slow oscillations are already replacing the waking patterns. In the next part of this story, we turn back toward the sun, toward the chromosphere and the photosphere, toward the surface features that drive the corona's complexity, and toward the instruments that watched April 8th from space while millions watched from the ground. For now, there is nothing to do. The shadow has long passed. The sun is on the other side of the planet. The corona is streaming outward into a solar system that continues quietly and completely without any effort required from you. Rest now. Everything is in motion, and you are still. That is exactly right. Sleep The surface of the sun is calling you back. The night has not changed. The room is the same. Your body is the same. Heavier now, perhaps, than when you first lay down. The kind of heaviness that is not weight, but release. The slow surrender of the muscles that have been holding you upright and ready all day, finally allowed to stop. You have been to the edge of the solar system tonight. You have followed the solar wind from the corona above Texas all the way to the heliopause where Voyager drifts in interstellar space. You have stood inside the physics and let it settle. Now we come back. Back to the sun, back to the surface, back to the place where all of it begins. The photosphere, the chromosphere, the structures that feed the corona its energy and its complexity. The place where the light we call ordinary daylight originates and where the corona's mysteries have their roots. Come back to the surface of the sun with me. Nonners, Perther you. The photosphere is what you see when you look at the sun with safe solar viewing equipment. It is not a solid surface. The sun has no solid surface. The photosphere is a thin layer of plasma, roughly 500 kilometers thick, where the sun transitions from being opaque to being transparent to light. Below it, photons are absorbed and re-emitted so rapidly that no individual photon can escape. At the photosphere, the density drops low enough that photons can finally travel freely outward. The light you see from the sun left the photosphere approximately 8 minutes and 20 seconds before it reached your eyes. The energy carried in that light began its journey at the core hundreds of thousands of years ago. The last 500 kilometers through the photosphere and across 150 million kilometers of space took 8 minutes. The photosphere has a temperature of approximately 5,500 degrees Celsius at its outer boundary, increasing to roughly 6,500 degrees at its base. The light it emits spans a broad spectrum, peak emission in the visible green-yellow range, near 500 nanometers, consistent with a black-body radiator at that temperature. The sun appears white to the human eye in space, and yellow-orange near the horizon on Earth because shorter wavelengths scatter more in the atmosphere. The photosphere is covered in granules, convective cells where hot plasma rises from below, spreads laterally as it cools, and sinks back down at the darker edges. A typical granule is roughly 1,000 kilometers across and lives for about 10 minutes before being disrupted by the rising and falling of neighboring cells. At any given moment, roughly 4 million granules cover the photosphere simultaneously. The entire surface is in constant churning motion. Every square kilometer of the sun is alive with movement. The surface you see is never still. Nor. Embedded in this churning surface, wherever the magnetic field is strong enough to suppress the convection, are sunspots. A sunspot is a region where a concentrated magnetic flux tube, a bundle of field lines with a combined strength of around 1,500 to 3,000 Gauss, compared to the sun's average field strength of just a few Gauss, pierces the photosphere. The strong field inhibits the convective transport of heat from below, causing the plasma in that region to be cooler than its surroundings. The temperature at the center of a large sunspot, the umbra, is typically around 3,500 to 4,000 degrees Celsius. The surrounding penumbra, where the field is less concentrated and convection partially resumes, is somewhat warmer. At 3,500 degrees, the sunspot is still incredibly hot by any earthly standard. but the surrounding photosphere at 5,500 degrees is so much brighter that the sunspot appears nearly black by contrast. It is not dark, it is dimmer. Sunspots typically appear in pairs or groups with opposite magnetic polarity, one spot where the magnetic field lines emerge from the sun's interior, another where they return. They form when rising convective plumes carry magnetic flux to the surface and concentrate it. They dissipate when the magnetic field weakens or disperses back into the photosphere, a process that can take days to months depending on the sunspot's size and stability. During the April 8th eclipse, the sun's photosphere contained multiple active regions, groups of sunspots at various stages of development, consistent with the approach to solar maximum. These active regions were the anchors of the coronal loops and helmet streamers you saw above them in the corona. The corona's complexity at that eclipse was a direct consequence of the complexity of the photospheric magnetic field beneath it. The surface drives the sky above it. Monlamoni. Above the photosphere is the chromosphere, a layer approximately 2,000 kilometers thick, where the temperature rises from about 4,500 degrees at its base to roughly 20,000 degrees at its upper boundary. The name comes from the Greek word for color. The chromosphere is responsible for the reddish-pink fringe visible at the edge of the moon during totality, produced primarily by hydrogen emission at H-alpha. The chromosphere is not a quiet layer. It is filled with dynamic structures. Spicules are thin jets of plasma that rise from the photosphere into the chromosphere at speeds of 15 to 30 kilometers per second, reaching heights of up to 10,000 kilometers before falling back. At any given moment, roughly 100,000 spicules are active across the sun's surface, creating a forest of moving plasma that covers much of the chromosphere. Each spicule is roughly 500 kilometers wide and lasts between 5 and 15 minutes. They carry mass and energy upward from the photosphere, and some researchers believe they play a role in transporting the energy that heats the corona. Fibrils are longer, more horizontal structures in the chromosphere, arch-shaped plasma structures that follow magnetic field lines near active regions. They are visible in H-alpha imagery as dark, elongated features threading through the chromosphere. Near sunspot groups, fibrils fan outward from the sunspot in patterns that trace the underlying magnetic field topology. And then there are filaments, or prominences, when seen at the solar limb. These are the structures you saw in pink at the edge of the moon's disk during the eclipse. From above, from satellite imagery, they appear as dark, thread-like structures running across the chromosphere in regions where the magnetic field is organized horizontally, suspending the cooler, denser chromospheric plasma above the hotter photosphere. A filament can be stable for weeks, slowly evolving as the magnetic field changes beneath it. Some filaments disappear quietly, their plasma draining back to the surface. Others erupt, suddenly rising and ejecting their material into the corona and beyond as a coronal mass ejection. The pink you saw at the moon's edge was the chromosphere, a 2,000 kilometer layer of plasma above the sun's surface, emitting hydrogen light, suspended between the photosphere below and the corona above. 3 layers, each hotter than the one before it. Each one connected to the other by physics that science is still working to fully describe. Morzo the Farska. The transition between the chromosphere and the corona is called the transition region. It is very thin, only tens to hundreds of kilometers in some places, and across it, the temperature rises from roughly 20,000 degrees to over 1 million degrees within an extremely short vertical distance. The density drops sharply in the same distance. In the chromosphere, the plasma is dense enough to be partially opaque to certain wavelengths of light. In the corona, it is so tenuous that it is transparent across almost the entire electromagnetic spectrum. The transition region emits primarily in the extreme ultraviolet and soft X-ray portions of the spectrum, wavelengths that cannot penetrate Earth's atmosphere and must be observed from space. NASA's Solar Dynamics Observatory, launched in 2010 and still operational, observes the transition region and corona continuously in multiple ultraviolet and extreme ultraviolet wavelengths. Its instruments image the Sun at 4096 by 4096 pixel resolution in up to 10 wavelength channels every 12 seconds. The result is an uninterrupted, high-resolution record of the Sun's atmosphere in multiple temperatures simultaneously, from photospheric temperatures visible in certain channels to multi-million degree coronal plasma visible in others. SDO data has been used to study coronal loops, flares, filament eruptions, and the evolution of active regions in more detail than any previous solar telescope. It was SDO's magnetic field data that Predictive Science Incorporated used to build their real-time corona model for the April 8th eclipse, continuously updating the simulation as new measurements of the photospheric magnetic field arrived from the spacecraft. The eclipse prediction and the ground truth, the model and the observation, each one testing the other. Warners warned. In the weeks before April 8th, 2024, a large active region designated AR 3614 crossed the Sun's disk. It contained a complex sunspot group with multiple polarities and a history of producing flares. In the days around the eclipse, the Sun also produced several M-class flares, moderate events on the solar flare energy scale from various active regions. The flare energy scale uses letters and numbers. C-class flares are small, M-class are moderate, X-class are the largest. Each letter represents a tenfold increase in peak X-ray flux as measured at 0.1 to 0.8 nanometers by NOAA's GOES satellites. An X1 flare is 10 times more energetic than an M1 flare. An X10 flare is 10 times more energetic than an X1. The largest flare ever recorded was an X28 event in November 2003 during solar cycle 23. The flare saturated the detectors on GOES, and the true peak may have been higher. On April 8th itself, the Sun was relatively quiet compared to its surroundings days. No major flares occurred during the eclipse window. The corona observers had, by chance or by fortunate timing, a relatively stable configuration to observe. Active, complex, and near maximum, but not mid-eruption. If a large coronal mass ejection had launched from an active region at the limb during totality, observers would have witnessed the corona's structure change in real time, a slow brightening and expansion visible over the course of minutes. This has been documented in eclipse observations before. It did not happen on April 8th. But the Sun had the capacity for it. It always does, near maximum. The eclipse observers were fortunate in the timing. The Sun chose that morning to be beautiful rather than violent. Duller Suro. Your breathing is very slow now. The body is doing less work than it has done at any point in the last 16 to 18 hours. Your core temperature has dropped slightly, a normal consequence of the circadian rhythm, which coordinates not just the sleep-wake cycle, but dozens of physiological processes, including thermoregulation, hormone release, and cellular repair. The temperature drop typically reaches its minimum in the early morning hours, a few hours before natural waking. This cooling is part of sleep's function. The brain and body, operating at slightly lower temperatures, process the day's cellular activity more efficiently, clearing waste products from neural tissue, consolidating the day's information into longer-term storage, repairing microscopic damage in muscles and other tissues. Sleep is not passive. It is the most active maintenance period the body runs, but it runs without your involvement. You do not need to manage it. You just need to stop. The sun does not need to think about its nuclear fusion. Your body does not need your instruction to rest. Nortains, for themes the verbors. Let us return one last time tonight to the corona. Not the corona of April 8th, 2024 specifically, though that one will remain in photographs and data and memories for the rest of the century, but the corona as a permanent feature of the sun, the corona that is burning right now on the far side of the planet from where you lie. The corona's total luminosity, the total power it radiates, is small compared to the photosphere. The corona emits roughly 1/1,000,000th of the sun's total light output. This seems impossible given the temperature difference. The corona is actually orders of magnitude hotter than the photosphere, but temperature alone does not determine how much light a plasma emits. Density matters just as much. A hot but extremely tenuous plasma emits far less total energy per unit volume than a cooler but much denser one. This is counterintuitive. 1,000,000 degrees should produce blinding light, but the corona is so diffuse, with particle densities measured in billions of particles per cubic meter near the base, compared to roughly 10 to the power of 23 particles per cubic meter in the photosphere, that its total emission is small. The corona's 1,000,000-degree temperature is carried not primarily in visible light, but in X-rays and extreme ultraviolet radiation. These are the wavelengths in which the corona glows most brightly, the wavelengths that ionize Earth's upper atmosphere and drive certain components of space weather. In visible light, the corona is only detectable against the backdrop of the unlit sky, which is why eclipse conditions, or the use of a coronagraph that artificially blocks the photosphere, are necessary to see it at all. The corona is not subtle because it is dim. It is only invisible because the photosphere is so brilliantly bright. The moon, on April 8th, gave us a dark sky in the middle of the day, and in that darkness, the corona appeared. It was always there. Porn of Sainov. The 2024 eclipse generated data that will be analyzed for years. Ham-size radio study of the ionosphere collected observations from over 6,000 amateur radio stations and continues to be processed. Teams using high-altitude research aircraft are still working through their coronagraphic and spectroscopic datasets. The citizen science balloon campaigns have provided atmospheric data at time resolutions that no stationary measurement network could have produced. Predictive Science Incorporated's corona model, updated and tested against eclipse observations, will be refined and used for future space weather prediction. And the next eclipse, in a different year, a different phase of the solar cycle, observed by instruments not yet built, will provide another comparison point. Science does not proceed in single observations. It proceeds in series. Each eclipse adds one more data point to a long chain of observations, stretching back to the first time a human being understood what they were looking at in the sudden midday darkness and thought to record it. The earliest reliable scientific observations of total solar eclipses date to the 19th century, though eclipse records appear in Babylonian astronomical tablets going back to 2000 BCE. Each observation, from the clay tablets to the WB-57 aircraft, is part of the same slowly accumulating understanding. We have been watching the corona for a very long time. We are still learning what it is. Rarest or prive. The room is very quiet. You have been lying still for a long time now, long enough that the distinction between the science and the half-formed images behind your eyes has become soft. The corona becomes a shape. The solar wind becomes a feeling of slow movement. The granules on the photosphere become a pattern that repeats without meaning. This is the edge of sleep. Not the far edge, not the deep, dreamless center of it, the near edge, the dissolving border where the waking mind's precise categories begin to loosen and flow into each other. You do not need to resist it or encourage it. It is just happening, the way the solar wind flows outward from the alven surface without deciding to flow, the way the granules rise and fall without choosing to convect, the way the eclipse shadow swept across Texas at 2,500 kilometers per hour without anyone accelerating it. Processes that began long before this moment are completing themselves now. Let them complete. The corona is streaming. The heliosphere holds its shape. The magnetosphere deflects the solar wind around the planet. The aurora glows in the north. The sun burns at the center of all of it. 4 million metric tons of mass converted to energy every second. Patient and constant and ancient. You are held inside all of that. The last part of this story moves gently to the end, to what happens to the sun itself in the long future, and to what that means for the last total solar eclipse that will ever occur on Earth. But that is a long and quiet road, and you are already nearly there. Rest now. Let the corona burn without you watching. It does not need your attention to continue. It never has. Sleep. The night is at its deepest now. Not darker than before. Darkness does not deepen the way sound does, but the night has reached the hour when even the restless have gone still. The hour when the city outside, if there is a city, has reduced itself to its minimum operations. The hour when the air is coldest, when the dew collects on surfaces that have been radiating their heat into the clear sky, when the animals that move in darkness are furthest into their territories. You have been here for some time. Your breathing is the slowest it has been all night. Your body is as still as it knows how to be. The science that has been moving through this room, the corona, the solar wind, the photosphere, the heliosphere, has settled into something quieter than knowledge. It is just the background now, the texture of the dark. Let it stay there. We are almost at the end. Milmo War. The sun is 4.6 billion years old. In geological terms, the Earth formed from the same cloud of gas and dust as the sun, roughly 4.54 billion years ago, about 60 million years after the sun ignited. From the beginning, the moon has been present, though it was much closer in those early epochs. Current models suggest the moon formed from the debris of a collision between the young Earth and a Mars-sized body called Theia, roughly 4.5 billion years ago. In the immediate aftermath, the moon may have been as close as 20,000 to 30,000 kilometers from Earth, close enough to appear enormously large in the sky, subtending many times the angle it does today. At that distance, total solar eclipses would have looked very different. The moon would have covered not just the sun's disk, but a large portion of the surrounding sky. The corona would have been hidden beneath the moon's vast angular size. The alignment that makes modern total solar eclipses so scientifically extraordinary, the near-perfect match between the moon's apparent size and the sun's, was not yet possible. The moon has been moving away from Earth for 4.5 billion years at the rate of roughly 3.8 centimeters per year. This recession is caused by tidal interactions. The moon's gravity raises tidal bulges on Earth, and because Earth rotates faster than the moon orbits, the bulges are carried slightly ahead of the moon's position. The gravitational attraction between the bulges and the moon transfers rotational energy from Earth to the moon, gradually accelerating the moon into a higher orbit and slowing Earth's rotation. Over billions of years, this has slowed Earth's day from roughly 6 hours to the current 24, and moved the moon from its close formation distance to its current mean distance of 384,400 kilometers. The eclipse you watched on April 8th was only possible because the moon has been drifting outward for 4.5 billion years to exactly the right distance. A few 100 million years too early, the moon would have been too large to allow the corona to be seen. A few 100 million years too late, the moon will be too small. You lived in the window. Behrenswartz. The window is closing. The moon recedes at 3.8 centimeters per year. In approximately 600 million years, the moon will have moved far enough from Earth that its apparent angular diameter will be smaller than the sun's. When that happens, the moon will no longer be able to cover the solar disk completely. Total solar eclipses, as they exist now, with the black disk of the moon perfectly fitting over the sun's photosphere and the corona revealed in all its structure, will cease. What will replace them are annular eclipses, events in which the moon's disk is smaller than the sun's, leaving a ring of photosphere visible around the edge. The corona will still be outshone. The diamond ring effect will not occur. The temperature drop will be less extreme. The midday darkness will not come. The last generation of human beings, or whatever beings occupy Earth, who will be able to stand in the moon's umbra and see the corona with their naked eyes, live somewhere in the next 600 million years. We do not know when exactly. The rate of lunar recession is not perfectly constant, but the window is finite. It will close. The eclipse of April 8th, 2024, was one of the last few 100 million opportunities. There will be others before the window closes. The 2044 eclipse over North America, eclipses in other regions and other years, but each one is finite, countable, bounded by a clock that has been running since the moon began its outward journey. Every total solar eclipse that has ever been observed by a human being has been a gift from the particular moment in lunar orbital history in which we find ourselves. Norn suing. The sun itself is also changing. Stars of the sun's type, G-type main sequence stars, sometimes called yellow dwarfs, follow a well-understood evolutionary path. The sun is currently in the middle of its main sequence phase, fusing hydrogen into helium at its core. As it ages, the helium accumulates in the core, and the core slowly contracts and heats. In response, The outer layers of the sun expand, and the sun's luminosity gradually increases. Over the course of the sun's main sequence lifetime, its luminosity will increase by roughly 10% per billion years. 4 billion years from now, the sun will be approximately 40% more luminous than it is today. The effects on Earth's climate will become severe long before that. Models suggest Earth's oceans may begin to evaporate in roughly 1 to 2 billion years as the increasing solar radiation drives a runaway greenhouse effect, even without any human influence. In approximately 5 billion years, the sun will exhaust the hydrogen in its core. The core will contract under gravity while the outer layers expand dramatically. The sun will become a subgiant and then a red giant, a star with a radius that may extend to roughly 200 times its current size, enough to engulf Mercury and possibly Venus. Whether Earth will be directly engulfed or merely scorched into a barren rock as the outer layers expand depends on details of the mass loss process that are still debated. The red giant phase will last for approximately 1 to 2 billion years. During this time, the sun will shed its outer layers in a series of increasingly powerful stellar winds, eventually ejecting most of its mass as an expanding shell of gas and dust called a planetary nebula. What remains at the center, the dense, hot, electron-degenerate remnant of the core, will be a white dwarf, an object roughly the size of Earth, but with a mass of approximately 0.5 to 0.6 solar masses. It will have no ongoing fusion. It will shine only by the residual heat it has stored, cooling slowly over billions of years, a dim, fading coal at the center of the dispersed remains of the solar system. In 5 billion years, the corona will be gone. The photosphere will be gone. The solar wind will have ceased. What remains will be cooling in silence. But right now, at this moment in the sun's life, at year 4.6 billion of a roughly 10 billion year main sequence, the sun is stable, consistent, and in the prime of its long middle age. The corona burns above you because the sun is exactly where it should be in its life. Or no, there is something in that worth resting in. Not sadness, not urgency, just the perspective that comes from holding the timescales. The sun has been burning for 4.6 billion years. In that time, the continents of Earth have moved across the surface of the planet. The oceans have risen and fallen. Complex life has arisen, diversified, been extinguished in mass events, recovered, and diversified again. The atmosphere has changed its composition multiple times. Ice ages have come and gone. The moon has moved away, centimeter by centimeter, year by year. And through all of it, the corona has been there, burning at 1,000,000 degrees above the photosphere, releasing its energy as X-rays and ultraviolet and the continuous solar wind, shaping the magnetic environment of the solar system, participating in the weather of Earth's upper atmosphere, producing auroras on every planet with a magnetic field. The corona was burning when the first photosynthetic bacteria began releasing oxygen into Earth's early atmosphere. It was burning when the first vertebrates developed. It was burning when the first hominids stood upright. It was burning on every human morning and every human night, visible in eclipses to anyone who happened to be standing in the right shadow at the right moment. And it was burning on April 8th, 2024, when 32 million people stepped outside along a corridor from Mexico to Newfoundland and looked up. 400 million years of possible eclipses. April 8th, 2024 was one of them. And you were there. Mona Ruff. The room is very still. Your body has been lying in one position for long enough that you may not be fully aware of it as a body anymore. Just a warmth, a weight, a slow rhythm of breath. This is normal. This is what rest does to the boundary between self and environment. The edges soften. The cells in your body are repairing themselves. The neural connections formed today are being consolidated. The muscles that held you upright are now completely released. The heart beats slowly and efficiently, its rhythm undisturbed by the demands of wakefulness. You have taken in a great deal tonight. The shadow crossing a continent, the corona above a Texas field, the solar wind flowing to the heliopause, the Parker solar probe inside the Alvin surface, the moon's slow recession across 4.5 billion years, the sun's remaining 5 billion years of burning. You do not need to hold any of it consciously. It is in you now, the way anything real and true settles in, not as a set of facts to be recalled, but as a change in the texture of understanding, a slight widening of what feels possible, a slight deepening of the context in which small things occur. The corona is burning, and you are resting. Both of these things are true at the same time. They do not conflict. Nonners the Briwa. On April 8th, 2024, in the 4 minutes and 27 seconds of totality over a field in central Texas, the moon held the sun's face dark and the corona appeared. It appeared because the geometry was exact. Within fractions of an arc second, the apparent diameters matched. It appeared because the moon happened to be at the right point in its elliptical orbit. It appeared because the solar maximum had filled the corona with active structures visible to the naked eye. It appeared because the atmosphere was clear. It appeared because people were there to see it. None of these conditions were guaranteed, any one of them different, and the experience would have been different. But they were all true at once on that morning. The corona appeared. White, streaming, silent, ancient, million-degree fire above a black disk in a darkened sky. And it is still there now. Above the atmosphere, above the planet's slow rotation, above the night that holds you, the same corona in a different configuration today than it was that day, but the same phenomenon, burning the same way it has burned since the sun formed. It does not need to be seen to exist, but it is very good when it is. Everything you heard tonight is real. The corona is out there right now. Thank you for being here tonight. Quiet Science at Bedtime is still a very new channel, and it means more than I can say that you chose to spend this time with the science of the universe. If this helped you rest, if the corona and the solar wind and the shadow crossing a continent gave you somewhere to rest your mind while your body found its way to sleep, please consider subscribing, leaving a like, and turning on notifications so you hear about the next episode. Every story on this channel comes from real research, real spacecraft, real measurements, real scientists spending real careers trying to understand the universe we all live inside. There are more stories where this one came from. The universe is not running out of material. Sleep well tonight. And the next time you step outside on a clear day and the sun is overhead, too bright to look at, too familiar to think about, remember that above it, invisible in the blue sky, the corona is streaming outward at 1,000,000 degrees, carrying the solar wind across the entire solar system. It is always there. Good night.